Hello everyone, welcome back. In this video, we will be covering section 4.8, which is Newton's method. Newton's method is used to find an approximation to the actual root of an equation. So when the degree of the polynomial is 2, then it's easy to find out the root. The degree is 3, it's okay. But if the polynomials have higher powers, then it becomes very hard to get the root. So this Newton's method helps us to helps us to approximate the root of an equation. Suppose we wanted to solve an equation such as 48x times 1 plus x to the power 60 minus 1 plus x to the power 60 plus 1 equal to 0. We know how to solve quadratic equations, and there are formulas. And for third and fourth degree polynomials, they are extremely complicated. If f is a polynomial of degree 5 or higher, there are no actual formulas. One way to solve higher order problems is the Newton's method, or in other words, it's also called the Newton-Raphson method. The geometry behind Newton's method is shown in figure 2. So in this figure, where the root that we are trying to find is labeled as R, we start with the first approximation x1, which is obtained by guessing or from a rough sketch of the graph of f, or from a computer-generated function of f. Consider the tangent line L to the curve y equal to f of x at the point x1 f of x1. And look at the x-intercept of L labeled as x2. The idea behind Newton's method is that the tangent line is close to the curve, and so its x-intercept, x2, that is close to the x-intercept of the curve, the root that we are seeking. So if you look at this graph, so this is y equal to f of x is this graph. And we want to find out the approximate value of the root of the equation. Let's say the actual root lies here. Actual root is, let's say it's not an easy number. It's not a whole number. It may be like 2.1113 something. So that is the actual root. Now what we have to do is we have to find out a root, approximate root for the equation, which could be done by mean value theorem, which could be done by sketching the graph or using the graphing calculators. First, we will do the first approximation, which is, let's assume that to be x1. Then if you draw the vertical line, it meets the graph at x1 f of x1. Then you draw the tangent line to the curve, and it meets at x2. Can we find out the value of x2? Yes, because we can find out the equation of the tangent line at x1 f of x1 to the curve, and we can see where the graph crosses the x-axis by setting the y value to be equal to 0. Now, the expectation here is that x2 is closer to r than x1, right? Then we are going to find out, we are going to consider the point x2 f of x2 on the graph and draw the tangent line to the curve at x2 f of x2 and see where the graph crosses the x-axis. That will be x3. So the expectation is that x3 is even closer to the actual root r than x2 and x1. So we make this approximation more and more, then all these approximations will come closer to the actual root of the equation. So this is one way of finding the actual root, or finding the closest approximation to the actual root by Newton's method. So if you consider that first approximation to be x1, let's assume that x2 is the second approximation. So if we consider the equation of the tangent line at the x1, so we are finding the equation of the tangent line at x1. For this equation of the tangent line at x1, f of x1. So you know the point through which it passes. We know the slope also. Slope is nothing but the derivative of the function at x1. So which is nothing but f prime x1. So we notice that the equation of the tangent line is y minus y1 equal to m times x minus x1. Here slope is the derivative at the point x1, and y1 is the y coordinate of the point at x1. So y minus f of x1 equal to f prime x1 times x minus x1. Now if we want to find out the x-intercept, we have to set the y to 0. So in the previous equation, y becomes 0. Y minus f of x1 equal to f prime x1 times x minus x1. And then we want to see where the graph crosses the x-axis. Wherever the graph crosses the x-axis, which is the x-intercept, we will consider that to be x2. If you label that to be x2, and you solve for x2 in this equation, f of x1 equal to f prime x1 times x2 minus x1. So if we divide both sides by f prime x1, providing it is not equal to 0, is to get cancelled out, then what is x2 equal to? x1 minus f of x1 over f prime x1. So this is the second approximation of the root. Second approximation of the root of the function f of x. Now similarly we can find out. So we have got a formula for x2. x2 is the second approximation, which is equal to first approximation minus f at the first approximation over f prime first approximation. Suppose you do the same thing, and what we have to do is in the graph, then you draw a vertical line and see where it crosses the curve. It will be crossing at x2 f of x2. Then you draw the tangent line at x2 f of x2, which is a second approximation, tangent line at the second approximation. And then you see where that tangent line crosses the x-axis, that is x3, which is even closer to the actual root than x2 and x1. Okay, so x3 is second approximation minus f at second approximation over f prime x2. If we continue this process, n plus first approximation would be nth approximation minus f at the nth approximation divided by f prime at the nth approximation. So this is the formula for finding the n plus first approximation. So the formula is given here. You have to remember that the denominator should not be equal to 0. And the point of this is, remember that when you take the first approximation, then we get to second approximation, third approximations, and so on. It should be, all these approximations should be coming closer and closer to the actual approximation. They should not be going away. So starting with x1 equal to 2, find the third approximation, namely x3, to the root of the equation x cubed minus 2x minus 5 equal to 0. So we are going to find out the third approximation. So let's do the problem manually, and then also we can learn how we can effectively use the graphing calculator to do this problem in a much shorter way. So let's do the math now. Let's find out the actual method. So the first approximation is given. So this is equal to 2. This is given to us. And what is second approximation? That is the first approximation minus f at first approximation over f prime at first approximation. So this is the second approximation. So what is f of x? F of x is given to be x cube minus 2x minus 5. So what is f prime x? Which is 3x squared minus 2. So if we use x2, what is x1? x1 is given in the problem 2 minus f of x1, which will be 2 cube minus 2 times 2 minus 5 on the numerator. On the denominator, it's 3x squared minus 2 with x replaced by 2. So it will be 3 times 2 square minus 2. So we can compute this manually here too. Minus 8 minus 4 minus 5 divided by 12 minus 2. So it is going to be 2 minus 8 minus 9, which is a negative 1, divided by a 10. So which will be 2 plus 1 over 10, which is going to be 2.1. When the first approximation is 2, second approximation comes out to be 2.1. Then what is the third approximation, which is what we have to find out, which is second approximation minus f at the second approximation divided by f prime at the second approximation. x2 is now 2.1 minus f of 2.1 divided by f prime of 2.1. So which will be 2.1 minus, so these are f of x and f prime x. And in this, we are going to substitute 2.1. So it is 2.1 the whole square minus 2 times 2.1 minus 5 divided by 3 times 2.1 the whole square minus 2. We can use your calculator to compute this. This value will turn out to be 2.0946, approximating to 4 decimal places. So check with your calculator for this part. As we see a pattern here, so this is our third approximation in the problem, which is the third approximation to the root. To the root of f of x. Now, how do we do this in the graphing calculator? So as we see a pattern, every time we used this particular formula. So we can, in y1, you can plug in f prime, you can actually plug in f of x. In y1, you can plug in f of x. In y2, you can plug in f prime x, evaluate and plug in. Then you create y3, which is x minus y1 over y2, because y1 is after all f of x. The denominator is f prime x, so y1 over y2. And then you need this x2 every time, or x2 or x3. So we call it dx, x minus y1 over y2. Then you will be going to the home screen by clicking the quit button. Then in that one, you will be computing y3. If assuming the first approximation is 2, to find the second approximation, you do y3 on the home screen, you do y3 at 2. This will turn out to be 2.1. Then you do y3 at 2.1. That will give us 2.0946. We'll try to do this in the graphing calculator. So I'm going to open up my calculator here. So the very first step, you plug in y equal to, and then you plug in what the function is, which is x cube minus 2x minus 2. So x cube minus 2x minus 5. And then in y2, find out the derivative, right? The derivative of the function that you've written on top in y1, which is 3x square. Is 3x square then minus 2. That is the derivative. And you create one more where the formula is for x3, it is x2 minus f at x2 over f prime x2. Right? So the formula that we are going to use is x minus, you have to bring in y1 and y2. So which is VAR, YVAR, choose y1, then divide. Maybe we want to have a parenthesis here. Then VAR, YVAR, and then the first one, divided by the second one. Divided by the second one, which is y2. VAR, YVAR, y2. y1 over y2. So now you go back to the home screen by hitting second and mode. This one, assuming that x1 equal to 2 is the first approximation. Now your goal is to find the second approximation. So which is VAR, YVAR, and we are going to pick this y3, and then we are going to plug in 2. This is the first approximation. So which turns out to be 21 over 10. If you compute that in decimal, it will give you 2.1. Now you are going to take that answer and you are going to plug it into y3. Right? So you do this for VAR, YVAR, and y3. Then you hit the answer in the previous step. The answer is the last line in your graphing calculator, which is in yellow. So click on second and this negative symbol and click that. That is going to give us the next approximation in fraction. We will convert that to decimal. So this will be 2.0945, etc. Now we are asked to approximate it to 4 decimal places, which you are going to do as 2.0946. That's exactly the answer that we got in our hand method. But this is the graphing calculator method is easier for, suppose you are finding, say, 8th approximation or 9th approximation, so you don't have to manually compute these values. So in this exercise, in the videos, section videos, you will see practice test number 6, 11, and 13. All these problems are done in the section videos. Please check them out. So watch my next video on 4.9.